Bill Nye, widely known as the Science Guy, has long been a beacon of inspiration for generations of science lovers. With his unique blend of charisma, humor, and deep scientific knowledge, he has been thrilling audiences for decades. From classroom televisions in the 1990s to major science panels and public media today, Bill Nye continues to fuel our curiosity with cutting-edge discoveries and fascinating explorations of the natural world. His passion for unraveling scientific mysteries has introduced millions to concepts ranging from biology and chemistry to environmental science and, notably, space exploration. One of Bill Nye's most captivating contributions is his ability to make space, the final frontier, feel close, comprehensible, and alive with possibility. He has piqued our interest in the vast and enigmatic universe beyond our planet, helping us to comprehend its sheer scale and the questions it holds. As humanity looks upward into the infinite expanse above us, Bill has been there to guide us, asking the big questions: where did we come from? Are we alone? What lies beyond? Now, in a new era of astronomical discovery, Bill Nye turns his attention to the James Webb Space Telescope, JWST, a marvel of engineering that promises to fundamentally reshape our understanding of the cosmos. This next-generation observatory has already provided some of the most breathtaking images and data ever captured, offering glimpses of the universe as it existed over 13 billion years ago. These images don't just impress visually, they challenge and redefine our understanding of time, space, and life itself. The JWST is not merely a telescope, it is a technological triumph and the culmination of decades of planning, collaboration, and ingenuity. It was launched into space aboard an Ariane 5 rocket on Christmas Day, December 25, 2021, after more than 20 years of development by NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The deployment of its massive sun shield, the unfurling of its golden hexagonal mirrors, and its perfect calibration at the second Lagrange point, L2, nearly 1 million miles from Earth, was a monumental achievement in itself. By June 2022, astronomers began to uncover an astonishing number of previously undetected galaxies, some older and farther than anything the Hubble Space Telescope had ever seen. These galaxies may have formed as early as 150 million years before Hubble's oldest recorded galaxies, pushing the timeline of cosmic evolution back further than once thought possible. But it's not just galaxies. The JWST can collect faint light emitted by stars, planets, and even the building blocks of life. It has the extraordinary ability to analyze the atmospheric compositions of exoplanets, planets that orbit stars beyond our solar system. With this capability, scientists can speculate with greater confidence about whether these distant worlds might harbor the conditions necessary for life. One of the most iconic images from Hubble was of the Pillars of Creation in the Eagle Nebula. These towering structures of gas and dust have now been re-imaged by the Webb telescope in stunning infrared detail, revealing dozens of protostars forming inside the dense clouds. To the human eye, they appear as tiny red dots, each one a future star in the making, some of which may eventually give rise to planets and possibly life. According to Bill Nye, these protostars are still in their earliest stages and not yet undergoing hydrogen fusion. But when enough mass gathers and the gravitational pressure rises, the core temperature spikes to around 2 million degrees Celsius, igniting the process that powers stars, including our own sun. The Webb telescope doesn't just show us the stars, it lets us watch them being born. The colors seen in these images are not what the human eye would normally perceive. The Webb detects infrared wavelengths, which are beyond the visible spectrum, and assigns them visible colors to help us interpret the data. In these representations, the cooler dust and gases show up in vibrant reds and oranges, while hotter regions or denser star-forming areas might appear electric blue. This technique reveals features invisible to other telescopes and allows scientists to literally see the unseen. Turning to exoplanets, the search for worlds beyond our solar system has taken a huge leap forward with JWST. While over 3,000 exoplanets have been confirmed since the 1990s, most have only been detected indirectly, by observing the dimming of a star as a planet passes in front of it. Only a handful have ever been directly imaged. That changed in September of last year, when JWST captured an image of the exoplanet HIP 65426b, a massive gas giant nearly 12 times the size of Jupiter. This planet is located so far from its star, 100 times the distance between Earth and the Sun, that it was possible to isolate it using specialized coronagraphs and infrared filters on Webb's instruments. The clarity of the image and the depth of the data astonished scientists, giving them a clear look at the planet's structure and atmosphere. Another major discovery was of the ghost galaxy M74. Previously faint and difficult to study, the galaxy was brought to life in a breathtaking infrared image from Webb. It revealed wisps of hot, glowing gas stretching out from the galactic core like glowing filaments, highlighting active star-forming regions in stunning detail. This composite image, combining data from both Hubble and Webb, was part of the PHENGS project, which aims to map and understand star formation in nearby galaxies using a combination of space and ground-based observatories. In another striking image, the massive star Wolf-Rayet 140, WR140, nearing the end of its life, was observed with JWST. Notable for its concentric rings of dust, the star revealed patterns resulting from its powerful stellar winds colliding with its smaller companion star. These ripples, appearing almost geometric, give astronomers insight into the late stages of stellar evolution and the material ejected before a potential supernova. But the JWST's crown jewel may be its detection of some of the oldest galaxies ever observed. In December last year, astronomers working on the JADE's extragalactic survey revealed 4 ancient galaxies dating back to 13.4 billion years ago, a time when the universe was only 350 million years old, just 2% of its current age. Using near-infrared spectroscopy, they were able to confirm their distance through a method called redshift measurement, which tracks how light stretches as the universe expands. These galaxies hold secrets about the very dawn of time and the early formation of cosmic structures. And finally, JWST has conducted one of the most detailed studies of an exoplanet's atmosphere to date, WASP-39b, a gas giant located about 700 light-years away in the constellation Virgo. Orbiting its star extremely closely, 8 times closer than Mercury is to our Sun, this planet experiences intense radiation, boiling its atmosphere. Using 2 of Webb's spectrographs, scientists detected the unmistakable presence of carbon dioxide, along with sulfur compounds and silicates, crucial elements in the chemistry of life. From protostars to ancient galaxies, and from boiling exoplanets to ghostly spirals of light, the James Webb Space Telescope has opened our eyes wider than ever before. And with communicators like Bill Nye helping to translate these discoveries into compelling stories, the wonder of the universe becomes something we can all share. Let us know your thoughts in the comments. If this inspired you, be sure to like and subscribe to stay connected to the cosmos.